Hi everybody, it's Mr. Gray here. Just like in the addition strategies quiz, I wanted to take some time and go over the subtraction strategies just so we all have a good idea of what are some of the things that are happening, some of the possibilities of this question. So it will look very similar, but of course we have some different strategies. So the first one says, Coach Diane put out 512 tiny cones during kickball. That would take a long time. The first team picked up 226 cones. How many were still left on the field? So before we even get to different strategies, one of the things we want to make sure kids are moving forward in are having different ways to think about the question. And so even though they're really big numbers, I can kind of draw a picture and figure out what's happening. Because, I want to think, is this an addition problem? Is it a subtraction problem? Of course, I think it says subtraction on the quiz. That's a good hint. But, even if I just thought of other numbers, said, what if Coach Diane put out 7 different cones? And then she picked up 5 of them. What's happening? Well, that kind of seems like subtraction. So that's probably what it is here. So some students will be able to identify that really quickly, but if you talk to your kid about this and they feel a little confused, I need to think of some other way to think about it, and drawing a picture is one of those ways, okay? So we have this idea now, and we know that I have 512 and I'm taking away 226. So I want to show you all the different strategies we went over in class. Just like for addition, some of them are more efficient than others, some of them make more sense at different times. And one of them was basically not used by anyone, but it would be a great way to think about it. So one way I can think about this is counting backwards on a number line. And there's a lot of different ways to think about this. This is going to be a great one because it shows a lot of flexibility in thinking, because there isn't exactly one way to do it. There's one kind of general format, and then I need to figure out how to do it from that. So I'm going to start at 512, and I'm actually going to count backwards. Now, because the numbers are easy, I can count, maybe I can jump back 200. Maybe I can do that right away, because I know that if I have 512 and I take off 200s, I'm left with 312. Maybe that's what I'm going to do. Maybe I'm going to count by hundreds. I don't know. But I still need to take away 26 more. And so now we get into the place where I need to think, how am I going to do this? So if I can think of 26 as broken apart into 12 and 14, that makes it easy because I know I can quickly take away 12. Now, I might have seen it a different way, but it's helpful to be able to break apart 26 like that. Maybe I thought of 26 as 10, 10, and 6. So I would take away 10, take away 10, and take away 6. So that would be a different way to do it. But I see it as 12 and 14. So I took away 12, and I'm at 300, and I still have 14 to go to take away. So I'm actually going to take away 10 now, which gets me to 290, and then I'm going to take away 4 more, which gets me to 286. All right? So that is a really good way to do it. And again, I did it, using this kind of break apart, but if I thought of it this way, I might have done it slightly differently. But if I use the counting down strategy, I would have had to do something like that. Now, the strategy that no one really used, because it is a little bit more of an advanced way to think about that, is the counting up strategy. Now, when I do subtraction, let's say I had a small number. Let's say I had 12 minus 7. Now, another way to think about 12 minus 7 is the distance between 12 and 7, or 7 and 12 on a number line. So if I know that 12 minus 7 means just whatever distance this is, if that's what I'm trying to figure out, that distance, then I don't need to think about it so much as subtraction as I can think about it as 7 plus something equals 12. So the same thing here. These are going to have the same thing right there. So I can also think about this as 226 plus something equals 512. And that sometimes is a little bit easier because I don't need to just subtract and borrow and do all those things, but I would have to know that this relationship exists. And I think that for our class this year, we didn't get to a place where we were really comfortable with that idea. But hopefully talking about it and revisiting it will help. So I'm going to show you what that looks like. This is the counting up strategy. So I'm actually going to start at 226. And I'm going to count my way up to 512. Now, again, just like counting down, there's more than one way to do this. I could actually jump up to 526 and count back. but I'm going to do it a different way. So I'm going to start at 226, and I'm going to take a big jump of 200 to get to 426. And now again, there's different ways to do this. I might jump 80 because I see that 420 to 500 is that 80 number. I might do it other ways. Okay, so then I'm at 506. So I have 280, and then I only need 6 more to get to 512. So I jumped 200, 80, and then 6 more. I have to add up these ones to see what the difference was. Like I said, I could have done this slightly differently. I could have jumped from 226 up to 300, to 5. I could have jumped up 300 to 526. And then I could have gone backwards 10 to 516 and backwards 4 more to 512. So I jumped up 300, I went back 10, which is 290, and then I went back 4 more, which is 286. Again, that's like one of the more advanced strategies because you're breaking apart all these numbers. But that's also can be a very efficient strategy depending on the numbers. So that's the counting up strategy. So we did counting down and counting up. The other one is maybe what we started subtraction with in first and second grade is the borrowing strategy. So it looks just like addition. So again, I had 512 minus 226. So I have 500s. I have 110 and 2 ones. And this is kind of the mechanism we learned about borrowing through, and then that will take us to the algorithm. But by using the kind of the place value borrowing, I can't take away 6. I need to take away 6 from the ones, and I can't yet. So I'm going to take this 10 and move it over, and so I'm all done with the 10. There we go, all done with the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So I still have 512. I have 512 ones. I still have 512. I just rearranged it. And now I can take away 6, which I will do. Okay, and I have 6 left now. Okay, so I still need to take away 220. I've only taken away 6 so far. So I can't take away 20 yet because there aren't 2 10s. So I'm going to take one of the hundreds, and I'm going to bring it over. I'm going to borrow, and I'm going to make 10 10s from that. Now that I have 10 10s, I can take away 2 10s, and I have 8 10s left. And now I need to take away 2 hundreds, and I'm down to 4 hundreds left because I borrowed one. So I am taking away 2 hundreds, and I'm left with 2 hundreds, 8 10s, and 6 ones. That is like kind of like if I was physically moving them around. Now, that becomes a not very efficient strategy because it takes a long time. And now that we're getting into bigger numbers, into hundreds and then into thousands, this strategy takes a long time, which is why we move on to the algorithm. And this is the exact same because I can't take away 6 from 2, so I need to borrow over here. And I took 110 and I put out here. So I have 12 ones minus 6 is 6. I don't have enough 10s to subtract. So I'm taking one of the hundreds, and I have 4 left. And I'm moving it over. So now I had 0 10s, but now I have 10 10s because I took one of the hundreds. 10 10s minus 2 10s is 8. And then 4 hundreds minus 2 hundreds is 200. So I have 286. Those are kind of all the different ways we went over it. I think when we did addition, that was like a little bit easier to come up with a lot of strategies. And subtraction is a little bit harder. But we want to have really like at least one strategy that I feel really comfortable about. If you feel really comfortable about the number line strategy and you always get it correct, that is great. That's a great one to use. Over time, we want to move everyone toward this one. We want all the kids to know the algorithm over time. But like I said, the counting up strategy might be the most advanced strategy to use just because of the mental gymnastics you have to do to use it. And then because of that, sometimes it can be very efficient. If kids are using this strategy, the place value one, over time, we want to move them toward the algorithm because it's a more efficient version of that. Okay, and then, just like last time, which strategy is the best? It's going to take your student to kind of explain. Another thing we want to kind of lift our level in is being able to say why. Often students will say, I like this strategy because it's fast. Well, what makes it fast? And hopefully, the student is saying, I had all these options for strategies, and I chose one for a reason. I chose the number line strategy because I was able to make really large jumps really quickly. Like I looked at the numbers and I said, oh, I could quickly jump 200, then 20, then I can see it in my mind. Or I chose the algorithm strategy because I feel comfortable doing borrowing, and this is the most efficient way to do that. That's a lot to ask for third graders, but that's kind of, what we're thinking. If I'm on that track, if I'm going toward an answer like that, that's really what we want to do. Okay, there's some review in here throughout the year. We're going to have some kind of spiraling review. We haven't taken a whole amount of time to go over data displays and making and interpreting bar graphs, but a couple of weeks ago we did go over, just over the course of a day or two, looking at some bar graphs. So this is a little bit of review, and like I said, we'll have review throughout the year. So when we take a multiplication quiz, there'll be some addition and subtraction on there because we want to keep practicing those skills. So we're going to use the bar graph to answer the question. The first one says, which club has the most third graders? We're going to go right to the top of the bar graph, and you might see students making lines, which is great because they can kind of see where those line up, and then they need to figure out, this is a little bit like a number line, or really it would be like that. It's like a number line, so I need to figure out that this must be 11, 12, 13, and 14. And so I can see drama has the most, and if I wanted to know, it would be 14. Which club has the least? Well, I can see the yellow box has the most, and if I were curious about how many, I could see, and again, I could do the number line, and this must be 6, 7, 8, and 9. So music has the least, sad for music. And then how many total third graders are in the art and sports clubs? So that one's going to be a little bit of a challenge. I have to see that art has 9. Art has 9, and I have to see that sports, I have 12. Sports has 12. A lot of times, when we were doing this, kids were asking for rulers, which was a great strategy so they could really line it up. Sports has 12, so altogether that is 21. And so that's kind of a little quick review of bar graphs in there, and just we're looking at them. I didn't ask them to make any this time, but that's something we'll get into, of course, later. Find the difference, 914 minus 159. So I have lots of different strategies that we talked about. I can tell you which one I would use. I would use the counting up strategy because I see some very easy numbers. And I see that this is close to 160, which means I can just go up 1 to get to 160. And then I can go up 40 to get to 200. And then I could quickly jump 700 to get to 900, and then finally 14 gets me to 914, excuse me. And then I could just add those quickly all together. 740, 14, and 1 gives me 755. And of course, if I'm feeling comfortable, I can use the algorithm and do some borrowing. It's going to be like that. 14 minus 9 is 5. I'm going to need to take one of the hundreds and make it 10 tens, and I have 5 right there, and then 150. Oh, I'm sorry, this is 159, so this is 755. There we go, that makes sense. And even that, what I just did right there, is a really kind of good thing we want to practice is, I thought this was a 7 for a second, and that doesn't make sense because 914 minus 159 needs to be a fairly large number, several hundreds. And so I had to kind of reassess for a second. So that was actually a 1 right there. Okay, so I could have used whatever strategy. And the final thing about that is we're trying to get being very precise. So if I'm a little bit off, that's okay because I knew what to do, but also we want to be precise and get the right answer. Okay, find the sum. Kids have different strategies for doing this. They're all great. As long as I have some strategy, maybe I'll add these two numbers together first. Maybe I'll add these two numbers together first. Maybe I'm just going to line them all up. And use the algorithm this way. Whatever way they want to do it is just fine. Again, as long as they have a strategy, they have an idea, and that they're very precise. So 6 plus 8 is 14, plus 7 is 2 10s and 1 1. 2 plus 5 is 7, plus 1 is 8, plus 1 is 9. So that's 9 10s, and then 5 hundreds. I also could have added 118 and 17 first, which may be as helpful. I'll have to see. So I get 5 there, 3, and 1. So I get 135. That maybe is really helpful because then I can just quickly add 456. And I get 5 hundreds, 8 10s, and then 11. So I'll just move that over, and this is a 9, so I get 591. So I could have done kind of, that's like a combination of strategies. Either one would work. Okay, what time does the clock show? Again, this is a quick review. We're going to have more time to go over this later in the year because we're telling time to the minute in this case, but I know some students know this, and we did kind of practice this. I can see that the hour hand, the small one, is past the 2, but it hasn't gotten to the 3, so it must be the 2 o'clock hour. And if I count by 5s, I might know it also, but if I count by 5s, on the 5 is 25, so this is 26, 27, 28. I also might know that this is 30, and I can count backwards from there. So either way, I get 2:28 a.m. or p.m., don't know. Santiago Hills has 517 students, round the number of students to the nearest 100 this time. Last time we were rounding to the 10. You can think about it a lot of ways. The kids might see that this 517 is less than 550, so it's going to round down to 500. They can make a number line and see that 517 is going to be way closer to 500 than 600, so it's going to round down to 500. And finally, Mr. Gray found 306 pencils, probably a true story at the end of its school day. They're all over, who knows why. Some were sharp and some were dull. In fact, 98 were dull. So how many were sharp? So again, I need to kind of think, what are they asking me? And so I might think of, a giant group of pencils of 306, and some of them are dull and the rest are sharp. So I need to kind of take out the dull ones to know that there are sharp ones left. So I'm doing 306 minus 98. Now, I'm going to do the number line strategy on this one because we are very close to easy numbers. So what I'm going to do is I'm going to start at 306 and I am going to jump back 100 to 206 and then just move up 2 to get 208. Because those are so close, like going back 100 and then plus 2 is kind of like the same as going back 98. Or I could use whatever other strategy, but I happen to see that one really close to 100 makes me think that I could use one of those strategies, and I get my final answer, which is 208. That is the subtraction, celebration of knowledge. Again, as always, let me know if you have questions, and really take this opportunity to talk to your students about different strategies and what they see and what they don't understand, maybe what you understand and don't understand as the parent for using these different strategies. Those are all really great conversations.